So trig identities. An identity has two sides, a right-hand side and a left-hand side. And for all values of the variable that you've been given, an identity is always true. We learned two basic trig identities to help us with the more complex identities, and you are expected to learn these and be able to use them all the time. So the identities that we learn is that tan theta is always equal to sine theta over cos theta. Okay, and obviously this works both ways. So if you have a tan theta, you can replace it with sine theta over cos theta, or if you had a sine theta over cos theta, you could replace it with tan theta. The other identity that we learn is that sine squared theta plus cos squared theta is equal to 1. Sorry, let me just get rid of. Alright, sine squared plus cos squared is equal to 1. That's our square identity. And it only works, it's got to be sine squared and it's got to be cos squared, and they have to be added together. Okay, you can't just split it and say sine plus cos. It's got to be sine squared plus cos squared is equal to 1. Okay, these two basic identities we use, and we have to be able to prove them. So you could be asked to reproduce the two proofs that we're going to do on the next page, and we prove them with an x, a y, and an r. So if you remember when we started the section on trig on a Cartesian plane, we said that this angle here, theta, has the coordinates x, y, and the terminal arm we call r. Right, so if I asked you to prove that tan theta is equal to sine theta over cos theta, we're going to start with a more complex side. So we're going to start with a sine theta over cos theta. So what we're going to do is we're going to say, well, that is the right-hand side of my identity. Okay, so this is the left-hand side, and this would be the right-hand side. Okay, so for the right-hand side, we have got that sine theta. I'm just going to change it into divided by cos theta. Okay, sine, save your rear. So sine is y over r. Cos, x raised. So cos is x over r. Okay, so save your rear. That's cos x raised tan your exterior. Okay, so that was the little rhyme we had. All right, so now we simplify this. So this is y over r times, so we've changed division to multiplication, so we invert the r over x. Okay, and can you guys see that this r would cancel with that r? So that's going to leave me with y over x. And what is y over x equal to? It's equal to tan theta. So you have proved that sine theta divided by cos theta is equal to tan theta. So that is the left-hand side. So we've proved the right-hand side is equal to the left-hand side. Okay, what about the other fundamental identity? Okay, sine squared plus cos squared is equal to 1. Now I'm going to start with this side. This is a more complex side, so I'm going to start with the left-hand side. So now I'm going to have to try and prove that the left-hand side is equal to this one, this right-hand side. All right, so the left-hand side says sine squared theta plus cos squared theta. Sine, we said just now, save your rear, and it's got to be squared. Cos x raised. Okay, so we're going to one term, so we like to square the top and square the bottom. Square the top, square the bottom. So if you can see, it's already got an LCD of r squared. And do you remember we said when we were doing this beginning part that x squared plus y squared is always equal to r squared? So we're going to replace this top part here. That's the same as that. So I'm going to replace x squared plus y squared with r squared at the top. R squared over r squared is 1, and that is equal to the right hand side. Alright, so that's how we prove these fundamental identities. But once we've proved them, we just use them as straightforward replacements in our more complex identities. Okay, so you don't prove them every time. You just use them as tan is equal to sine over cos, and sine squared plus cos squared is equal to 1. Okay, the other thing I wanted to remind you about is that algebra rules your trig. So when we're proving identities, 99% of the time we're actually using algebra. We actually need to see the algebra in the trig. So I just wanted to show you some quick examples. So if I said to you, multiply sine theta over cos theta by cos theta, we would use our normal algebra rules. Okay, so whole number, so it would get a denominator of 1 because I'm multiplying whole numbers and fractions. So we would put this over 1, and then we would multiply numerator times numerator and denominator times denominator. So that's going to give me sine theta times cos theta over cos theta times 1. And then this is what we were doing in the first section. Remember, we've got one term over one term, so that could cancel with that, and that's going to leave me with sine theta. So just a reminder, we've already done this, but just look for your algebra. Okay, here I have two terms. Okay, 1, 2. They are not like terms. This is a sine theta, this is a sine theta times cos theta. If they were like terms, we could add them or subtract them. Okay, so if you have terms that are not like terms, we need to factorize. And when we factorize, remember the first thing we always look for is there a common factor? And yes, I'm hoping you guys can see that the sine theta that I've written in orange here, it wouldn't be orange normally, is a common factor. So we need to take that common factor out. Let me just quickly do this. If I gave you m minus mn, okay, so this sign is like the m, and the cos is like the n. If I gave you that, you would take out the m as a common factor. Then you would divide m into the first term, and you would divide m into the second term. Okay. Right, so that's taking out a common factor. So we're going to do the same thing here. We're going to take out the sine theta as a common factor. That is my highest common factor. Okay, that means I have to divide this first term by sine theta and the second term by sine theta. Okay, so if we divide sine theta into the first term, everything's going to cancel and you're going to be left with a 1. Okay, and if you divide it into the second term, can you guys see the sine will cancel and you'll just be left with a cos theta. So it's normal factorizing. We're just using the trig like we would be using algebra. Okay, here we've got two terms again. They're not like terms. So to make it into one term, we would factorize it. Okay, there's no highest common factor. So we ask ourselves, can we do a difference of two squares? Okay, if you guys remember your difference of two squares, if I gave you x squared minus y squared, you would tell me it was x minus y and x plus y. Okay. If I gave you 1 minus k squared, you would tell me it was 1 minus k and 1 plus k, because the square root of 1 is 1 and the square root of k squared is k. So I'm going to do the same thing here. It's two terms. The square root of 1 would be 1. The square root of cos squared would just be cos. And then don't forget it needs another bracket of 1 plus cos theta. So I can do a difference of two squares on 1 minus cos squared. All right, in the last example we have fractions and we want to add them. And if we want to add fractions, what do we need? We need a lowest common denominator. All right, so what is my lowest common denominator? Well, I would need a sine and I would need a cos. So I'm going to write that as my common denominator, a sine theta from the first one times a cos theta from the second one. Okay, so there's my LCD. All right, so what do I need to multiply sine theta by to make it into sine times cos? Well, I would need to times this by cos, because that would give me sine cos, and what I do to the bottom I must do to the top. And what do I need to multiply cos theta by to make it into sine cos? Well, I need to multiply it by sine, which means I have to multiply the top by sine. Okay, so it's just like normal fractions. What do I do to the bottom? Now I must do the same thing to the top. Okay, so what's going to happen here is sine times cos would be your sine cos at the bottom, and cos times cos would give you cos squared theta. And sine times sine would give you sine squared theta. Okay. And then, what do we know? But we know from our identities that sine squared theta plus cos squared theta, that's our fundamental identity. So I'm going to replace this cos squared plus sine squared, which is the same as sine squared plus cos squared, with a 1. So this thing at the top here, that's equal to 1. So this is going to give me 1 over sine theta cos theta. So it's all about the algebra. The only trig in number 4 was replacing the sine squared plus cos squared with a 1. Everything else was algebra. Okay, so we're going to do one or two identities, proving these identities. So I've just written here, this is our 1. Tan theta is sine theta over cos theta. And if you're given a tan squared, it would be equal to sine squared over cos squared. Okay, so it's the same identity, they've just squared both sides. And then this is the other one, sine squared plus cos squared is equal to 1. Okay, so what we normally do is we replace our tan with sine over cos, so that we're working with just cos and sine. Okay, And where do you start? You start on the more complex side. Okay, so which side has got more terms? Well, in this case, it's the left-hand side. So I would be starting on the, so here, left-hand side is 2 terms. Therefore, start on the left-hand side. All right, so we start by going left-hand side is equal to cos theta times tan theta plus sine theta. Okay, then we replace our tan with sine over cos. Okay, so that's what we're doing. Cos theta times sine theta over cos theta plus sine theta. Okay, now remember we've got whole numbers. So my whole numbers, so we're going to do multiply first. So we're going to be doing our multiplication, and can you guys see that this cos would cancel with that cos? Okay, that's one term at the top, one term at the bottom, so those can cancel. So we multiply and cancel in first term. And then we keep going. Algebra, so this is going to be sine theta plus sine theta. And what are these? These are like terms. Okay, so you've got 2 terms, they're like terms. We've looked at this in previous examples. So 1 sine theta plus 1 sine theta would give me 2 sine theta, and that is the same as the right-hand side. That is what we were looking for. We were looking for the 2 sine theta, and we've now come out with 2 sine theta at the bottom there. Okay, so we have now used our fundamental identity to make the left-hand side and the right-hand side to show that that is equal. Okay, here's another one. All right, so where do we start? We start with the more complex side, and more complex side would be the left-hand side. So we start with the left-hand side, and what does the left-hand side look like? It looks like this. Okay, so left-hand side, more complex, start there. Replace tan x with sine x over cos x. So sine x stays, cos x stays. Tan x becomes sine x divided by cos x. Okay, so again we've got 2 terms, so we've got to do the multiplication before we do addition and subtraction. So we have to multiply all of this. All right, so those get denominators of 1. And then at the top, you'd have sine x, cos x, sine x. At the bottom, you'd just have cos x. And again, this cos x at the top may cancel with that cos x at the bottom because it would be 1 term over 1 term. So that's going to give me sine x times sine x plus cos squared x. Okay, sine x times sine x gives me sine squared x. And what do we know about sine squared and cos squared? We remember that sine squared plus cos squared is one of our identities. sine squared x plus cos squared x is equal to 1. So the answer to this would be equal 1. And what is on the other side? This is the right-hand side. Therefore, my left-hand side is equal to my right-hand side. All right. Finally, we're going to look at one with fractions like this, addition and subtraction. So I just want you to first look at the blue at the side. I just want to remind you about algebraic fractions. So if we were adding these, we would need an LCD. Okay, so we would try and find one of everything. So we need an m, and we need a 1 plus n. Okay, so that would be my LCD. And then you'd ask, what do I multiply by? Okay, well, I need to multiply this by m, and that by m, and this by 1 plus n, and this by 1 plus n, to make them equivalent fractions. All right, so here I'm going to have m times m is m squared, and then I've got n times 1 plus m. N times 1 plus n there. Okay, now if we were doing the sum here, the next thing we would do is we would remove our brackets, because that's what we normally do in algebra. So we remove the brackets, so that gets distributed into there. So we've got m squared plus n squared over m times 1 plus n. And then we would look for like terms. And in this case, there aren't any, so this would be the answer to this side here. All right, so lowest common denominator, remove brackets and look for like terms. All right, so we're going to try that on this side. All right, just want to draw a nice line there. So I'm starting with a more complex side, which happens to be, again, the left-hand side. And we have sine x over 1 plus cos x over sine x. Okay, there's no tan, so I can't replace tan with sine over cos. So I start by saying we want to add fractions. So we need a lowest common denominator. And my lowest common denominator is going to be a sine x from the single there and a bracket, 1 plus cos x. Okay, so what am I going to need to multiply by? I'm going to have to times this by sine x. So I've got to multiply this one by sine x, and I'm going to have to times this by 1 plus cos x. So I've got to times this one by 1 plus cos x. So we're going to have sine times sine gives you sine squared x plus cos x times 1 plus cos x. Okay. So what do we do now? Well, if we look on the other side, now we remove the bracket. All right, so we're removing the bracket, distributing that cos times 1 gives you cos x, and cos times cos gives you cos squared x. Okay, now we ask ourselves, are there any like terms? And the answer is no. There are no like terms at the top. But what I can see, I have sine squared x plus cos squared x, and that is equal to 1. So I can replace the sine squared plus cos squared with a 1. And now, by putting brackets around the top, I am allowed to cancel that whole bracket. That goes into their ones, and that goes into their ones, because it's one term over one term. So I'm allowed to cancel. And that is equal to 1 over sine x. And where do you see the 1 over sine x? There it is on the right-hand side. So I've proved that the left-hand side is equal to the right-hand side. Okay, these just really take practice, and you're going to just need to keep trying to see the algebra to help you.